Hey everybody, in this video we're going to talk about finding the center, vertices, foci, and asymptotes of a hyperbola. Okay, so in order to find the center, well, we're given a nice equation here where the center of our ellipse, or our hyperbola, sorry, is always at hk. H is always attached to the x and k is always attached to the y. So our center is going to happen at -4 and a +8. Why a -4? Because with our equations of a hyperbola, we have x minus h squared. So in order to get this +4 to look like a minus a number, we have to do minus -4. So h is my -4 value. Okay, now in order to find the vertices, of my hyperbola are going to be dependent on A and B. And the reason I say A and B is because we need to consider which one's A and which one's B. For a hyperbola, the one that is a positive fraction, so the denominator that belongs to the positive fraction, meaning it's not being subtracted, is our a squared. So the 9 is a squared. This could be a 1. If it was a 1, it would still be a squared, even though it is smaller than 4, because it would be on our positive fraction. And you think of it as a positive is bigger than a negative anyways. And this portion is going to tell us that b squared is equal to 4. This a squared being over the y tells us the hyperbola is going to open up and down. We're worried about the y's. And here are our vertices here, and our foci are going to be here. So from this center point right here, in order to find the vertices, my vertices are going to be a distance of a away from the center. But that distance a is going up and down, which means I need to take my center, -4, and then to my y value, I'm going to add and subtract my a value, which happens to be 3. Because a squared equals 9. So my vertices are going to be at -4, and then 8 plus 3 is 11. And then my second vertex is going to be at -4, and then 8 minus 3, which is 5. So there's my two vertices right there. So I've done my center, I've done my vertices. Now let's go ahead and find my foci. Now my foci happen to be C away from my center. So that distance is C in the vertical direction again. So I'm going to end up with -4 and 8 plus or minus C. Now how do I find C? For C I need to know A and B. I know A is 3 and I know B is 2. And for hyperbolas, c squared equals a squared plus b squared. So that means c squared is going to equal 9 plus 4, or 13, which means c equals the square root of 13. So my two foci are at -4 and 8 plus square root 13. And also at -4, and then 8 minus the square root of 13. And there's those 2 points there. So now let's talk about the last one, and that is the asymptotes. It doesn't want me to write that without zooming in, so let's just go ahead and finish this off. Asymptotes, there we go. And then we'll zoom back out. Now, our asymptotes, the equation for our asymptotes when we are dealing with a hyperbola that is opening up and down, are y minus k equals plus or minus, so that's where our 2 different lines are going to come from, a over b times x minus h. So we can just plug in our values here. Y, k is 8. So y minus 8 equals a positive or a negative a over b, so 3 over 2, times x minus h, which is a negative 4, so we're going to do x minus negative 4 against x plus 4. Now let's do some simplifying. We get y minus 8 is going to equal, actually let's go back a little bit. Let's go back. There. I'm going to add 8 to both sides. So I get y equals a positive 3/2 times x plus 4 plus 8, or y equals negative 3/2 times x plus 4 plus 8. After I do some simplifying and some reducing here, I end up getting y equals 3/2 x plus 14 and y equals 3/2 x plus 2. How did I get that? I multiply this 3/2 through, and then I add 8. And then on the second one, I multiply negative 3/2 too, and add 8. So I should have a negative 3/2 right here for my slope on my second asymptote. So that's how you can find the center, vertices, foci, and asymptotes of a hyperbola.